And a few highlight or hands up. There is a lot of things I've observed in the machine learning industry for the last 2 years that I would like to mention to you. Okay, if you look at many machine learning enthusiasts or maybe deep learning enthusiasts, anyone who is interested in the field of data science and machine learning and artificial intelligence, they are focusing so much on building the models. How do they fit the model they have to the data? How do they fit the model to the data that they have? While they have left a lot of focuses on how to generate the data, they have left a lot of focuses on how they design business processes that will generate data for the algorithm they want to build. There is a less emphasis on how to handle the output that they have. Even there is a less emphasis on how they will build all the processes around the machine learning process. So I would urge you, or I would request you, as you start your career or as you build your career in data science and machine learning, make sure that you focuses on these processes. These include how to generate data, how to design business processes that will generate data for the algorithm that you want to build, and how to build all the processes around machine learning. Also, I would like to mention this. There are too much focus on how to build the model and not enough focus on how to integrate the machine learning models that they have built with the existing products that exist in the market. Still, okay, if you observe everywhere where the machine learning is applied, there is already existing product, and there is a need to implement the existing product with machine learning models that you are building currently. And that is why you meet many people are going wrong. They are focusing on how to build model, how to improve on the accuracy, and less focuses or less emphasis on how to integrate them with the existing product. So I want to welcome you to, okay, I think that is in and it has stuck. So as you start your career, as you develop yourself, make sure that you focuses on the field that they are violated. Now let's go to today's business, which is the first series. This is the second series for deploying machine learning models. Yeah, we'll be using Flask. So let me share my screen so that we can start. Just a minute. I hope you can now see my screen, and if you can see, just type in the chat box the software that you think I have, the operating system that you think I'm learning on. So to be sure that you can be able to see my screen, just type on the chat box the softwares that you can see on my screen, maybe in the operating system that you think I'm using. Yeah, just straight up like 3 people to type, then we can go on. Okay, cool. Now let's start our session. Again, I will say we are starting our session on deploying machine learning model, and I'll be back here so that we can start. Then I just move this to here so that it doesn't distract us much. Yeah. Then I will check if there is someone who have typed. Yeah. Thank you. I can see 3 people have typed. So we can just go and start the agenda of today. The agenda of today is how to deploy our machine learning model. Yeah, that is what we are tackling. But as it was indicated on the flyer that you used or you saw the event at, we'll be adding today the pickling process, how you pickle. Pickling the model is one of the processes that we have when deploying our machine learning model. Then there is something else I wanted to share about Data Science East Africa. You can be able to, you can check us on Twitter and follow for more notification about such event. Then there is this one thing that I wanted to mention about the emerging or the upcoming libraries that you should look at. They help you to speed and automate your machine learning process. They are new. Most of them have been developed since 2020 and 2021. And you can check on the full list here. I will be sharing the link so that you can visit the post, and maybe you can get more insight from the post. We have shared in-depth details about the same. Yeah, it has a thread that you can follow and read about every library that you have indicated there or framework. Something else I wanted to mention is that we'll have a series for the next 3 months, 4 months. We'll have a series of sessions that will discuss all these libraries one by one, their purposes, and so on by people in the development team, the core team developing this library. Some of them have volunteered for the event and will be approaching others on the libraries that we have not gotten volunteers yet. So I think I've shared that. Those are libraries that are worth the checking. Yeah, they are important. And as I've said again, we have volunteers who are willing to help us learn each library for each purpose. Yeah, 3 of them are core team for each library. Yeah, and we'll be sharing more about it. But meanwhile, you can check us on Twitter and make sure that you're updated by, you can check every post that you make. So direct the agenda of today, I will just open what we'll be sharing. And I'll be saying we'll be using this. Okay, as I mentioned in the last session, I mentioned the tools that we're going to use. And I'll start by discussing why we picked Flask. Okay, there are 2 alternatives that are competing very fast currently. We have Flask and Fast API, which are the 2 Python frameworks that exist for deploying machine learning models, or the process I said for integrating the machine learning models that you have built with the existing products. So why did you pick Flask? Flask, it is easy to use and easy to learn. You can check that from the official documentation. Okay, it is built in development server and debugger. It has built-in development server debugger, then integrated unit testing support, or you can even use the existing frameworks for testing Python code. Then there is RESTful requesting, departing, and extensively documented. Also to add, there are a lot of communities that will help you to learn and pick on Flask very fast. And this is the structure that we will be using to develop our project. Our project will contain the model.py. Also, before I say that, I'm not viewing the page. So in case you can't hear me or you have problems with or you have a question, you can just unmute yourself and ask a question. Also, I would like to request you to make the section as interactive as you can. So I want to be viewing the page that has the meeting. So kindly be sure to unmute your mic and ask any question that you have. If you type, I won't see. So let's go on. and discuss the structure of our project. Our project will contain three main sub-features. The first feature will be the model.py. This will contain our machine learning model that will predict. And we'll be using the sales for the first 2 months to predict the sale. We will be using rating, sales for the first month and sales for the second month to predict the sales for the third month. So we'll be using model.py file. This is the file that will contain all our Python file that will be used, or that will contain our machine learning algorithm or our machine learning model that we use to predict the sales in the third month based on the sales in the first 2 months. Then we'll also have app.py file. This will be a Python file that contains Flask APIs that receive the sales details from the GPU or the APIs calls that you make, compute the predicted value based on the model, and return it. It will return the predicted value based on the predictions that are made by our model. Then we'll have the request.py. This is another Python file. And this file, this uses the request module to call API. So it will use the request module library that we have in Python to call the API that we will define in the app.py, and it display the return values to the client or to the user. That is the file. The request.py is the file that is responsible for displaying this value that we have here. Sales should be, that price that is printed there. It is the responsibility of request.py to make sure that value is displayed there. Then we'll have the template of the UI for the page. This is the page now that we can see. And that page will be developed using CSS and HTML. Okay. Also on this, I want to mention something that is very fast. Okay, there is this library that is called Streamlit Python library for building UIs. Yeah, you can read this article, and I wanted to make an announcement about the library, or maybe I should share the link to the library itself so that you can have a look at it. Just a minute, or I can share. Okay, this is basically a machine learning library or a Python library that is used to develop the UI. Instead of using I can share, then I'll make the announcement later about the library. Let me share the link so that you can look at it in your free time. Yeah, we have the library there. And to be specific, on 22nd of May next month, we'll have someone from the core team that is developing the library. She will be taking us through. She has a lot of experience using Streamlit and Fast API. So she will be taking us through how to deploy our machine learning model using Fast API and Streamlit. So it is an alternative of these files. The index, the HTML and the CSS file. So you can either build your own. You can use a framework like Vue.js, React.js, or Angular, or you can use vanilla JavaScript, HTML, and CSS, anything that you feel you can use. So the HTML and the CSS, these files will contain the HTML template and the CSS stylings to allow users to enter sales details and display the predicted sales in the third month. So this is how basically our final product will be looking like. It will be a web application. Basically, it will be a second URL. Like we'll have the index the index route will have the predicted routed other route, but this will be part. It will be integrated in a basic, simple, maybe a hello world program, but it won't be a landing page. You try to make it more interactive so that it can look that like we have integrated the product in an existing product, business product that exists. So I think that is how basically our application will look like. This is the first structure that we'll be having. And we can move on to one of the topics that we'll be covering today. One of them is Pickle. And I want to introduce you to what basically is Pickle. Now, last time I discussed something very briefly, but I think I will mention it again. To be more specific, when you're building a Python library or a Python machine learning algorithm, let's say you are building a model to predict the sales in the third month, and you want to save this module so that you can make prediction. You cannot repeat the whole process. You can be only making the prediction. It is the job for a joblib package that we have in Python, to be specific in sklearn, to save that module that you have built, so that, okay, it is different when using keras, because in keras you just use save. But because in the bootcamp we are basically using sklearn, I will discuss it basing my explanation on sklearn. So there is a module that is called joblib. Its purpose is to save the machine learning algorithm that you have built and load it when necessary, instead of repeating the retraining process. Okay, this will save your time. This will save you a lot of time and maybe a lot of resources. Like, you won't repeat the whole process. So even the processes that will be running in your laptop, in your system, maybe it's your PC, they will be very, very few compared to the processes that you'll be learning when you come from cleaning, collecting the data, cleaning it, training it. Instead of repeating that process, now the process will be only to load the data ahead to make predictions. So that is the purpose of joblib. Then we have another package that is inbuilt in Python. It is called joblib, and they have written a nice article about the same. Maybe you can save this link and read about joblib data. So I think I'll share this. Yeah, it is an article that I wrote about joblib, and it is the article that I'll be using to explain what basically joblib is. So very fast, I'll go through joblib. We'll try to do few examples. After that, we'll look at how to package machine learning module. So very fast, we have joblib, and you might ask yourself, okay, sorry, I'm discussing Pickle today. You can check their official documentation. I will share the link later to the official documentation for Pickle, but I want to discuss now Pickle. Okay, you have to know, the first thing that you have to know is the basic one, that Pickle is inbuilt in Python. You don't use pip to install it. When you install Python, you have Pickle installed already. Done. So what is its purpose? Okay, Pickle is used for serializing and deserializing a Python object. Let's say you had a list and you want to serialize it and save it so that you can use it later. You have this very important function that you have built, and you want to package it in such a way that you can be able to use it later. So there, in that case, you'll use Pickle. Also, towards the head of the session, I will show you how to package your Python package to be able to install them using pip. Yeah. So there are two processes that are involved in serializing and deserializing. And what I want to tell you is, serializing is like you are saving, or you want to package that more object that you have so that you can use later. Then deserializing, now you want to unpackage the Python object that you package so that you can use it now. Serializing and de-serializing, they have a standard name. We won't use serializing and de-serializing again. I used it because layman's language that we can all understand. Basically, we'll be talking.
What is
Basically,
serializing and what is de-serializing?
just a minute. Okay, kindly the person who was asking the question, repeat your question.
You say that pickling is the serializing and de-serializing of a Python object structure. So what is serializing and what is de-serializing?
Okay, I want to mention this. Pickling is the same as serialization, and it is the process where we take a Python object and hierarchically, from the first line of code to the last line of code, that's what I mean by hierarchically, convert it into bytes streams and dump into a file using dump function. Okay, we'll be using dump function, that is, we have in Python. To explain to Edina what basically serializing is, have you ever worked with C++? When you learn a C++ program, it is converted into
Yes.
machine language. Now, that machine language, that file that is containing machine language, it is the file that we use to learn so that we can get the output. You understand that? Now, that is basically what serializing will be. We are taking our Python object, let's say it's a function or an array, we package it into machine learning, that is in binary format. Then when you want to use it, we are converting it back to a Python object and executing it. Now that is how it happens in C++. If you want to execute a C++ program, let's say hello world.cpp, when you execute that file, it will generate a file, maybe it's a.out. And this file that is called a.out is the file that we execute so that using G++, so that you can get the output that you needed. So that is the same case with serializing. So when I refer to serializing, I mean pickling. They are one thing. I think I've explained well. So we can go to the second step, that is unpickling. And that when I refer to unpickling, I'm talking about deserialization or deserializing. It is the inverse of pickling. Now we are converting the binary format into a Python object, and we do that again hierarchically. If you add your first line of code, it will, when we unpickle it, it will be the first line of code again. There won't be any confusion in between there. And now this is the process how we do it. I said Python comes with Pickle. All Pickle is inbuilt in Python, so you don't have to install it. What you have to do, you have only to import it. But before going on, you have to know these two main methods that we have in Pickle. The first method is dump, and the other method that we have in Pickle is load. The same case we have in JobLib, if you have worked with JobLib, if you had a chance to work with JobLib. You know, we have dump and load in JobLib that I used to save our model and to load our model when we need it. But in pickling, the first method is dump, okay? And dump, which dump is used to dump, so I don't know what I mean, or dump is used to convert or to pickle the Python object that we have to a file object. And the second method is load, which is used now to load the object or to unpickle the binary file that we have into what? Into a Python object that we initially had. Am I clear up to there? Maybe if you have a question or you have anything to add, we can chat on chat box before we go on to the real implementation. Anything you want clarified? If no, type no. If yes. If yes, say yes. Anyone with something that they want to be clarified more? Okay, it depends with what you want. But you know, as usual, you can't load a model that was not dumped. I'm answering the what another question. And we'll look at it just now. We start with dump, then we load the model. But if our model is loaded, we can't dump it again. Another thing that I would like you to know is how to handle files in Python. So maybe I will try doing files in Python. Yeah, we can look at this file, this article. It is well written. Okay, I can see your answer. Yeah, Frank is right. Christian is asking, a Python object here refers to what? A program, a function, or what? Yeah, it refers to anything that you have. If it's an array that you have, that is what we call an object. If we have a function, that is what we refer to as our Python object. If we add a whole class that is inside a file, that is what we refer to as an object. Object is in a Python program or source code or anything that you have written in Python that you want to save and use it later. So before we go on, I want to show you how to handle files in Python. And because I'll be just going through it briefly, I will share the link so that you can look at it later. Yeah, this is the link to the article that I'm opening right now. Yeah. I want introduction, you can read for yourself. They are saying that Python is one of the best programming that we have currently. I won't be reading it, but I will be reading on how to handle files in Python. The key functions used in file handling in Python are open, which is used to open a file, close, which is used to close a file. Then we have read, which is used to read a file. We have write, that is used to write into a file that you have opened. Then we have append, that is used to add a text or anything that you have inside the file that you have opened. Then I want to specify something. If you open a file, open is a method that is there in Python, and it takes few arguments. One of them is the file name, the file that you want to handle, the mode at which you want to handle the data. Then the other thing that is important is how to encode, the encoding format that you want to use. Then there are those methods that are common. There are those modes that are common. These are the modes that are there. But today I'll be discussing only two. The one that I'm highlighting now, RB, that is used to read files only in binary format. And I will also be discussing the WB that is used to open files, but it open files only in binary format into zeros and ones. I can hear a question. Just
Aaron, please, can you zoom out? Like zoom page.
sorry.
Ukifungua kwa that nini, that page ulikuwa unafungua, like you zoom out so that we can see.
Okay, thank you. But you can hear me? So confirm, kindly unmute your mic and confirm if you can view, you can look at it. Can you see it now?
Yes, iko sawa.
Yeah, so as I said, kindly unmute your mic. Kindly mute your mic. So I will repeat here. These are the key methods that or functions that we have in Python for ordering file. We have the open method. We have the close method. Open is used to open a new file or an existing file so that you can work on it. Then close is used to close any file. It is very important to note this. Whenever you open any Python file, make sure that you close it to avoid memory leakage. Another method that we have is write and append method. Okay, the write is used to write into the file. Then we have append method that is used to append any text that you want to append in the file that you have opened. Then I've said one of the important methods that we'll be using is the open method. And open methods takes a few arguments. The first one is the file name, the file that you want to work on, then the mode. Do you want to write it or to read it? Then the other thing that is important here that I'll be discussing is the encoding format. Yeah, so this is where you state the format at which you want to encode your file. I will repeat this for emphasis. Whenever you open any file in Python, kindly make sure that you close it at the end. It is very important. So, here you can see I've discussed something about mode. And we have several modes, but I will be discussing only two. Like R is for read only. We have RB. RB is only, it's for read only, but it reads files in which format? In binary format. Then we have WB. WB is used, okay, W is used for writing into a file. Okay, you're opening a file in light mode so that you can be able to write on it. Then you can write a file, but you can write only in binary format. You can see I've discussed on it too. And I've shared the article with you, can read the other. But why did I include only where we have binary mode? So that I said this, when we are serializing or when you are pickling, let me maintain the word pickling so that you can be able to get me, or we can flow smoothly. When you're pickling something, I said you convert a Python object that exists into what? Into a dump or into a machine language, that is the binary language. Then when you want to unpickle it, now when you want to access it or use it, we read that file and you read it in binary format so that we can convert it back to our Python object. Then another thing that I would like to highlight here is when you visit stackabuse.com, there is a lot of job highlight. Like on the right hand side, they gives you the options of remote job that you can apply. Just keep trying. Like here you can see there is a Python job here. It means someone who is a full stack software engineer and analytic, inahitaji akuwe full stack, akuwe everything. Yeah. So you can be checking these jobs. They are very important. Yeah, I think I can share so that you can check during your free time. These are places where you can get jobs. And I think Stack Abuse is one of them. Be sure to check it later. So I think we are clear up to there. You have understood the methods that we have in Python for reading files. Then you have understood the mode at which you can read the different files. Now let's move on and proceed and get a real example now. How can we pickle something in Python? So I'll come here and I will try to explain this code. The first step that we do is pickling. Maybe let's assume, I want you to assume or think in terms of machine learning. Think like this, like our fitted machine learning model. But for this example, you'll be handling a Python array. So I don't want you to view it as a list. just view it as an array, which is a Python object for storing more than one value. It's just a simple variable for storing more than one value. So the first step, as I said, you will pickle your object. After pickling your object, you'll move to the next step. And the next step will be what? The next step will be to define your Python object that you want to work with. Maybe you have that function, maybe that has 3 numbers, or you have that function that calculates volume. You have that function that views if a user is registered or not, and you want to pickle it. So the first thing that you want to do is have that object, Python object that you'll be working with. After importing the Python Pickle module and having the object that you want to work with, now here is where you have your file. Okay. So there is this one important thing I want to mention about this. It is very important to know. We have defined a variable to store our open file, okay? And we have called that variable pick out. What will it output? Like I want to store my file that I will store my object as. Now you give it a variable name that you want. Then use the open method that is there in Python to open a new file. When I run this code here in this line, I am expecting it to generate a file for me. I forgot to mention this. When you're pickling and you have to create a pickle file, whatever is generated is a Python file that it is a pickle file that is saved with an extension .pickle or .plk. PKL, sorry, that is the short form for pickle. So if I learn this cell, I'm expecting it to generate my pickle file.pkl. That is the extension for any pickle file. Then the second argument that open takes is the mode at which you want to add this file. And I want to add it, I want to write in the file. So the mode will be W, but I want to write what? I want to write machine language in that file. So that is the binary format. That's why you see when I indicated the mode at which I want to add my file in, I wrote WB to ensure that it is opened for write and it is to write in binary format only. Are we together? Now we have our Python object and we have a file where we want to store our Python object. What next? Now here is where the purpose of the dump method that we said it is available in Pickle comes. We are still together. I don't want to lose you anywhere. We said the first method is dump. It is a method that is found in Pickle. Now that is the time you call that method. And that method takes a few arguments. Among them is the Python object that you want to serialize or to Pickle. Someone is talking. Kindly, you can say whatever you want to say clearly, very fast, so that you can move on in the interest of time. Okay, thank you. I think I'll move on. She doesn't want to talk again. So in such an example, we are taking the dump method that is available in Pickle. Then I have said the dump method takes a few arguments. One of the few arguments is the Python object that you want to work with. Let's say you had your linear regression module, and this linear regression module, you made an object instance of it and called it model. Now that is what you pass here. Are we together? After passing it here, it takes another argument, that is the file, the variable that contains the file at which you want to store your binary. And okay, let me call it data. Whatever you have converted the object into, and you store it in a file, then you define a variable that will store that file. Then that variable is the one that you pass as our second argument. As I said again, if you open any Python file, make sure that you close that file. Are we together up to there? Just confirm if you are together.
Yes.
Okay, thank you. Let's move to the next step. I hope you have understood what really Pickle is.
Sorry, can you pickle Python script too?
Yeah. As far as it has something to output, you can package it. But I'll say this because you have asked right now. I wanted to say it at the head, but make sure you don't unpickle data from zinaitangwaji unsecure sources. If your source of data is unsecure, you don't trust it, make sure that you don't unpickle that data. So we can move on to unpickling process. Now, as I said here in the definition, unpickling process is exactly the inverse of the pickling process. And as usual, you start by importing the package, then you read the file in which you want to extract now your object from. And we know our object is contained in my pickle file. So I will open. So what I will do, I will open that file using the open method. Then when I open that file, I will store it inside a variable. Then I will open it in which mode? One mode, the int binary mode. We are up to there. Now, because we dumped our method, it's exactly the same the way we do it in joblib. Because we pickled or we dumped the method, now we have to load that object. Let me run this for the purpose. Now, if I run this, maybe I should do this. Yeah, so that I can do this. If I load the object, that means I'm loading what? I'm loading the Python object that we had. So in case I print my A, yeah, I'm expecting it to print the list that we had. Yeah. I hope the process is understood. Now, in reference to machine learning algorithm, I'll show you with this. Yeah. This is just for sure. I'm not doing it basically. So you can see here, I imported my linear regression from a scalar.linear model. Then I made an instance of it here. So when I want to pick all this, what I do, that is the model that I package. So that is where you see our dump method. The way it is taking the Python object, now it will take our machine learning object. Then it will take two more arguments, the variable that you had defined. But instead of doing it two ways, I've just decided to do it at once. So we'll look at this later. I want to make sure that you have understood what really is pickling. And after understanding what is pickling, here are the some of the use cases. And please, this is a disclaimer or caveat. Don't unpickle data from untrusted sources. It can be malicious code that you are unpickling unknowingly. So make sure that whenever you want to unpickle something, you trust it. Especially when you're storing Python object in a database. That is when you can use Pickle. Also to save a program state data to a disk so that you can carry it on where it left off when we started, or setting the Python data over TCP connection. Those guys who are in the deployment of Python object or hosting of the Python application can tell this. Then another one is converting an arbitrary Python object to a string so that it can be used as a dictionary key. It is called caching. It is used in examples for caching. Yeah, you can read this. It's boring. you can read this boring text later. So I think I'll share the link to the GitHub that I will store. Okay, I'll push them into a GitHub repository and I will share with you. Then very fast, I want to share with you this. What is linear regression? But before I do that, I promised you to show you something so you can look at it. We can take a look at it here. Before it opens, I want to discuss with you something else. Kindly learn how to load a file, a CSV file, maybe it's an Excel file that is in cloud. How can you load it using Pandas? That is an important skill that you need currently. Let it open. As it open, maybe you can. Okay, what exactly I want to show you, I want to explain to you, how can you build maybe your own Flask, okay? How can you build your own Django? And be able to, how can you build your own maybe NumPy and be able to install it using pip? So, it's boring today. Someone with a question? If not, let's go and open this repository that contains that file. I won't be doing a lot about it. Maybe I'll share, you can look at it later during your free time. Yeah, it's how to package a Python file. Let me remember how I saved it. Okay, you only need a file that is called setup too. And I think it's not this file. Oh, it was in a while, so I have Python netpub, yeah, somewhere here. It was allowed here. Don't know, let's see my it first. Hey, sorry. It's taking forever to get there. Huh? Hey. Sorry. Let's try to get it very fast. I don't remember how I saved it. It was in a while. You only need a file that is called setup tool. That is the only file that you need to create your own object. Maybe I will share it when I'm sharing the other one. I think we can't get it right now. But it is very simple. Actually, you only need to add one more file in your folder. And that file, it's just like how the way you do it in JSON. It's just like a JSON file, but this one is a setup tool. And we use it to package whatever we have. And just one more time, Flask. Google Docs. Practice. Okay, honestly, I can't get it now. If I say talking about it will take a lot of time. Oh, you can check later. I'll share. I'll be sure to share that. So let's get the wheel rolling and learn about linear regression. Okay, before you understand what is linear regression, that was another process, because the product that we are building here is this product. It is a linear regression model that we'll use to the first month and the second month sales to predict the third month sales. So it will be a linear regression model. That's why you see you have covered it basically here. I want to explain it very fast. So before you understand what is linear regression, you should understand what is what is regression, and very easily understand this. Linear regression is the example that you learned in high school, primary school. The y is equals to mx plus c. That is basically a simple linear regression. So regression is a technique used to model and analyze relationship between feature and the dependent variable. We can say features and the variables, the input or and output, independent and dependent variables. You can put it in any format that you need, but for a standard definition, just take it as a technique used to model and analyze relationships between the feature and dependent variable. When we come to what is a linear regression and when we want to understand linear regression, this regression model or this type of regression model, okay, tries to plot the relationship between a group of features. There is someone else who gave me something. When you want to understand regression, understand that regression, it starts with LRA. Also, when we have linear data, real value data, like 30, 40, we call them real. So regression and real are related. So when you're working with regression, understand that you're working with real numbers. So sorry for that. And this regression model, that is, I'm talking about linear regression. This regression model tries to plot the relationship between a group of features and the dependent variable by fitting a linear. So we are talking about a linear equation of to the observed data. So you have observed your data and you want to fit the data that you have observed to a linear equation. And this data contains features and the dependent variables. The formula for a simple linear regression is given by y is equals to b naught plus m plus b1 multiplied by x1. That is basically the same as, let me introduce a cell here. That is basically the same as saying m is equals to mx plus c. So when you're talking about the one that I have written y, take y to be our y, and this equals to mx. So take our b1 multiplied by, so I can put it into braces, x1. Or I can omit x so that I can have plus b naught. Okay, that is basically a same explanation, only that it is rearranged. So that I will move this to markup so that it doesn't disturb us and run it. Okay, so there are few things that you need to note about this. The first one is y. The y is the dependent variable that you're trying to predict. Then we have our x. Now our x is the independent variable or our feature. Okay, our dependent variable, you can also call it label. Then we have our b1. This is the coefficient. Sasa, you can also call it the slope of a linear line of the best fit. So I don't want to explain everything in details because this is not a mathematical class. I'll be sharing the link later. So the other thing that I need to explain to you is what is B. That is the constant term. So basically the same thing we had here. Y is equals to mx plus c, where m is the gradient, x is the independent variable, y is the dependent variable, and c is the constant, the same case here. Also, you have to note that when you talk about y being dependent variable, it is dependent on two things. The first thing is our x, and the second thing is our coefficient. Okay, you'll be looking at it later here. So taking basically an example, let's say you have a graph of x and y axis, and maybe x axis will hold the experience that you have in your software development journey. Then we have our y, which contains the salary that you earn at every age or at every level that you have. or experience level that you have. So we have someone who asks a question.
Yes, I think Juma Kenya is like raising his hand.
Sorry?
I saw like Juma Kenya was raising his hand. Juma Kenya, that is.
I didn't understand you. Kindly type the message or be louder. I'm still waiting on it. My senses tells me you want I zoom, so I've already zoomed. Let me see if I'm right. Did you want me to zoom?
Babu,
Yeah?
I think, okay, if I could add something on the regression,
On the?
linear regression,
Uh-huh.
I think the y is equals to beta naught plus beta 1 x1. That is just when you have one variable.
Uh-huh.
If you have like other variables, it could be y is equals to beta naught plus the sum of beta I,
Uh-huh.
xi. So I is maybe 1 to n, where n are the number of variables that you may
Uh-huh.
have. Yes?
Yeah, yeah. Sure. Okay, to make this clear, I just want to explain the simplest format of a linear regression that we can have. We can have multiple polynomial linear regression, but I'm not going in there. I just want to explain a basic linear regression. Is that okay, Edna?
Yeah, yeah.
Yeah, so I don't want to go in depth or in complex.
Aaron, please unmute.
Oh, sorry. Let me repeat again. So I'll start here. When I said this is the basic formula for linear regression, simple linear regression, then I said y is our dependent variable. It is also called, it's a simple, it's as, okay, I can call it a dependent variable, okay, that depends. You can also call it label. Then we have x is our independent variable, or we can call it input. You can also call it the feature variable. Then we have the b. This is the coefficient. It is also the slope of our line of best fit. Then we have our constant b naught. B naught is our constant term. Then, as I said earlier, is you have to know that we have said y, our label is it's a dependent variable. And you have to note that it is dependent into two things. The first one is the x, which is the feature variable or our input. And the second thing is our coefficient. That is our slope for the case of the line of best fit. And I was trying to give this example where we have a graph of x and y axis, where x axis it contains the experience count, while our y axis it contains the salary that you receive at a given level of experience. So what we want to know our plate rate. This is how much you earn at any given age. So our plate rate count depends on the age. If we plot the values of our data set, we may get the random plot over the graph. So when we have something like this, what we want to predict is our salary. So that is our y, or our dependent variable. Then we have experience, which is experience, which is now we can say the independent variable or input. Then we have this as our slope or our coefficient. Then something else to note very well, this is our constant. Let's say in a certain country, they have agreed to a certain base salary. Like, let's say we have decided that 20K is our base salary, then you can earn maybe from the experience level. Or we can say a company pays a junior developer maybe add a K as a start, then you earn, and your earning will depend on the experience that you have. Now, that is a good linear regression equation that can explain that. So let's see that in depth. So I said there is something called constant, and defining a constant, I have said a constant is a point where the line crosses the variable axis, okay? Where the line crosses the variable axis. So we have our equation here, the line of best fit is here, okay? Where the line of best fit meets the salary or the variable axis is where is what we call the constant, okay? This is just a photo to explain it. And if you can see at level 30K, that is where our line of best fit meets our variable axis. And to explain this, is I can say that this is the place where the line crosses the variable axis. It means that in the graph that is below, for my case, a person with 0 years of work experience or a junior, now we can say if you're talking about a developer, you can talk about a junior developer, will get the salary of $30K. Like that is the base where you start. That is what we call our constant. Then we have our B1. Our B1, we said it is our coefficient. For that case, we said it is the slope. And when you're discussing B1 now, when you look at it, what is basically is B1? B1 is the slope of the line. So you have to know how B1 affects the salary that you earn, depending on a certain experience that you have. I don't know if I'm clear. I will say again, B1 also affects the salary, or the slope, to say it in general, the slope affects the dependent variable too. So you have to know that the dependent variable is dependent on two things. The first one is slope, the second one is the independent variable. So talking of B1 is the slope of line, and the more the steeper the line, the more the salary you get. Like, yeah. So let's take a simple example where a person has 6 years to 7 years of experience. Then the salary, 6 to 7 years of experience, then the salary will increase with respect to the slope. If the slope is less, this is very important to note. If the slope is less, then the salary increase will be less. If the slope is less, the salary increase will be less. So you can look at it here, just assuming the one that you have is the base one, and maybe the slope has decreased. When the slope will decrease, then the salary increase also will be less. I hope I'm clear. I don't know how I should explain that further. Now let's go to plotting a basic best line of fit. Yeah. The best line of fit will look like this. And you have to understand a few things. Like you have to understand the distance between the red dot and the line that is there. Or now that is what is described here when I projected it out in the image. The red star and the green star. Then we have the green dots. So let's discuss about the green and the red plus symbols. So the red plus symbols is the place where the person is present in terms of salary. So the red is what you are earning, okay? Then on the green plus sign, okay, that is where we expect you to earn depending on our model. So that's why I'm saying the model line, that is the black line that is there, state where the person should be present or how much he or she should be earning according to the model in terms of salary. And according to the model, it should be somewhere very near to the linear, to the model line. For example, if the actual observation was $200, according to the model, it should be somewhere lower or near to the model line. Let's say something like $190,000. So something else to note here, it doesn't just means that when you model, you get the accurate data. It doesn't mean also the best line of fit, it passes through the most of dot. You remember in high school where you are told the line of the best fit is the line that will join the most number of dots. It doesn't work that way always. So you have to basically understand that, like the model line is the black line, the plus dot is what actually you're earning, and there is that distance between the model line and what you're actually earning. That is what I want to discuss next. Then when you talk about the red plus symbol is Y1, and that is the actual observation, while the green symbol is the Y naught, Y high naught, and that is the value with respect to the model, or that is the modeled value, and it is the point at which the red line is. Okay, I can say the green dot combines the red line with the model line, the red plus symbols with the model line. So there is that distance I want you to understand very well. To get the best fitting line, we take each of the green lines, okay, and the square. Talking of green lines, I mean the green dashed lines. Then we square them, we square that distance, and we take the sum of those squares, and we take the minimum value of it. So a simple linear regression draws a lot of green lines as in the above image and count the sum of those squares every single time and stores it somewhere, and then finds the minimum of those sums. Sum of squares. You see, count the sums of those squares every single time. Then it stores those sum of squares and finds the minimum among them. It looks for the minimum of the sum of squares, that is just a repetition. The line which has the smallest sum of squares will be best fitting line. The line that will have the smallest sum of squares will be the best fitting line. And this is the process that we call ordinary least square method. Okay, that is a unit in Compass that you can tackle later. I don't want to go in depth. Let's implement and see what I was trying to discuss theoretically. Okay, there is this data in terms of a dictionary. So basically, I expect you know how to convert a dictionary into a Python data frame and save it into a CSV file. That is done here. So you can look at it here. Jesus. Yeah, like you have a dictionary as a data set and you want to convert it to a data frame and save it into a CSV file. That is what I'm trying to explain right now. That's what we'll do with the data that is given here. Then, as usual, when you're working with the data science or machine learning project, the first thing to do is to have your data ready. After having your data ready, you import the packages that you'll be using. After importing the packages, now is where you load the data. After loading the data, you decide now what will be your independent and dependent variable. And to develop this data file, that is the CSV file that was created from a dictionary. This is the correct way of doing it. You import the pandas library. After importing the pandas library, then you have your dictionary and use pd.dataframe, then list data frame items, okay, data items, sorry, like you're getting every item using the items method that is available in dictionary, and then you're giving the the columns for your data set. And finally, I will have it as a data frame this way. Then I will have the data frame here. And later now I'm trying to save it to a CSV using .to underscore CSV method that is available in pandas. So that was fast and straightforward. It is basic skill that you are needed to have. I will share the file so that you can look at it later. So let's go on. So I've created a salary. When I run that cell, it will generate this file. That cell, it will generate this file. Then you have X and Y. That is the independent and the dependent variable. Then after that, now you split your data using the train test split method that is available in model selection module that is available in sklearn library. I hope I'm clear. Then the other thing that you do now, you use the method that you imported to, and this method takes a few arguments that I'll mention. The first one is the independent and the dependent variable that you'll be working with. The other thing that it takes is the test size. How much data do you want to maintain to remain for testing? Then random state. You can either omit it or pass the random state at which you want your operation to work on. Then you have to know this syntax, which I think it is straightforward. Like you want to split the data into the testing and the training data set. And now I want a third of my data set to remain for testing purpose. That's why I indicated the test size to be 1/3. Then now you come to the actual process of building your model, and it will be very simple. You start by importing the linear regression model that you'll be working with. Then you make an object instance of our model. Then you fit our model. And now you can use our model to make predictions. Because in the interest of time, I'll leave you to do one thing, two things actually. The first thing that I want you to do is to visualize the train set result. And the other thing that I want you to do is to visualize the test set result. You have to know it will be very hard because you are working with this type of data set, this type of data. And to ask your question, what type of data do you think this is? In the interest of time, I'll answer, and I'll say this is a NumPy array. For this case, it's a 2-dimensional NumPy array. So making these two plot, it will be very hard, especially when you're using scatter plot. So I want you to visualize this. Then you can post your result on Twitter, if you're on Twitter or LinkedIn, and you can you can use this hashtag. Yeah, you can use that hashtag so that we can know you had, or you can tag data science. That's called capital E, small letter E. So when you're done doing this, you can post it on Twitter, LinkedIn, and tag Data Science East Africa or Data Science East Africa farm. And we will be announcing the winner maybe in next week. We'll announce the winner who made the best plot and shared. You can also write an article about the same, and you share and tag us. We'll be discussing the winner next week at Data Science East Africa Twitter handle and Data Science East Africa on Medium. Now let's do the hardest part, or the most interesting part. I won't say it is the hardest. You can get the data set in this repository. We have converted it to raw so that we can be able to access it directly using pandas. And as usual, I want to be discussing the common ways. You import pandas, then after importing the pandas, you define a variable to store your URL. Then you read the CSV file directly from the variable. Then you meet our data will have missing values. So you are cleaning the data and making sure that there is no missing values. Then here you are doing some feature engineering where you want to convert. When you look at our data, let me print our data for that case dot end maybe. I hope it will work. Jesus. Yeah. Now, if you look at our data, you can see the rate as what? It has numeric data. Now, it has string data. So we have to convert that data into numeric data. And that's what we are doing here. We are trying to replace all the new string data that we have here, or the categorical data, that is NNA, then we have 4, 9, 7, up to 9. So we have 1 to 9 in our data if we predict so. And you can see there is NAN, so there is missing values. And we want to replace that missing values using the fill NA method that is available. I'm lashing here because I expect you know some of this. If you have been in the bootcamp for all days, I expect you know much about this. Then after filling the missing value, you are filling using the before fill, which is a method that is available for filling missing value. We also have this is before fill. It takes the below fill, sorry. Below fill, it takes the value that is below and fills the missing value with that value. We also have below fill and above fill. That is fill. You can also fill, like you meet there is a missing value here. Where am I writing? So you can take the value of 300 and replace it there. So that is basically what you're trying to do. Then the next step, you're trying to replace this string data to numeric data. That's why we are doing the replacement here. We define a dictionary, then we give the key a value. Each string data will give it a key of string data. Then we give it a value of numeric data that we want to replace it with. Then it returns that dictionary, that it returns our dictionary that we had and the parameter of our method. There is something I want to discuss before I move on. There are two very important methods that you should know. That is the anomalous functions in Python. There is a very nice article I got here for you. Yeah, these are functions that don't have name. Basically, when you're defining functions in Python, you use def followed by the function name. Okay, then you can pass maybe parameter, maybe 1 and parameter 2. Yeah, then you can return the pass value. So just for formality. That is how you define a function in Python previously, a normal Python function. But if you want to define an anomalous function, that is a function that doesn't have a name. You just use this lambda. Use this syntax, lambda. It is followed by the argument for your function, so it doesn't have a name. Then the expression of your function, and that works. For example, let me use this file for introduction. I want to define maybe anomalous function that will multiply x or that will square x. So because it is anomalous function, I will write lambda. Then it should be followed by what? So lambda is the keyword, like we used def, but when you define a function using lambda, it doesn't have a name. Maybe it takes the argument that you want to pass. Then after passing the argument, the expression, maybe you want to have x squared. Oh, it was x, so squared. And we learn it. We expect it to give the memory storage. Also, if you understand C++ and you know about pointers, I think this will not be something new to you. So if I have my function there, maybe I assign data variable, maybe let's say it is square. Just to avoid conflict of interest, then I can introduce a below cell my SQL. Then I can pass maybe 2. What do I expect? I expect 4. My function works correctly. Then there is another thing that I wanted. I don't know. I said this is the argument, this is the expression that you want to execute, and then I'm calling my function, or I'm invoking my functions. When you come to pandas data frame, we have this apply method, which is used to invoke a function on values of pandas series. There is something I have never mentioned, and I want to mention it today. So it is in this file. When I printed the data set, this whole data set is a data frame. It has rows and columns, but each column, like the first month sales, kama hii column and another column and this column, each column is called series. Okay, each column will be called series, and the whole of the data set is called a data frame. So if you want to invoke any function on the first sales month, maybe you want to square everything, you'll use this method that is available in pandas. It is called the apply function. So since I have discussed those, it will be very simple for you to understand here. Okay, I want to reference to the rate that we have in my data. There is this rate. And to this rate, I want to execute a certain function on it. This function is our function rep. The function that does what? This function will do what? The function is responsible for converting these strings values to numeric values. And that is the function that I want to execute on my rate series in my data frame. So I have to use apply. Then I have to use lambda to define an anomalous function. And this is an argument. Then this is the method that I want to call and invoke it on this series. Then now I've defined, I have to, from the data set, now I have to define my dependent and independent variable on my input and my output. You can also call them features and labels. So call it the way you want, but make sure that now we said we want to use this first sales and second month sales so that we can predict the third sales month. So this is our independent variable, and these two are our independent variables. So that is how you use. You can use drop method too. The drop method will work the same. Just drop this, and when you drop this, you'll be left with what? You'll be left with the first sales and second month's sales and the rate, and you'll use them to predict the sales for the third month. I hope I'm clear. You can use drop or ilogs, any method that you want to use that is favorable to you. Now let's build a machine learning model. So as usual, you start by import. Let me import it. Import Pickle. So as usual, start by importing the machine learning algorithm that is present in sklearn in the module called linear regression, linear_models. And I want to specifically use linear regression. Then after I have imported it, I can make an object instance of it. And this object instance will be stored in a variable called model. So this is like an object. Then we will import the library for Pickle library that we'll be using. After importing the Pickle library, now we are available to use the dump and the load model that we have. Okay. I don't know if you are still together. Yeah, you can see you are still together. So after that, now you move to the next where, okay, I will discuss this for clarification. You saw in our, when you wanted to serialize just a simple array, we opened the file in the right mode. Then, so this instance is what the dump method takes. So it takes the object that we have And our object in machine learning example is the algorithm that you'll be using. The next argument that you take, it is a file. And this file, because you want to serialize it or to pickle it, you have to open it in the right binary mode. And the file will be called sample.pkl. That is the file extension for Pickle file. Then after if we learn this cell, we expect it to, we expect it to generate a new file called sample.pkl. Let's see if we are correct. Now you can see it generated this file. It's not necessary to look at it because it is a binary form file. You can't be able to look at it on the web. Then after now having that file, you can open it to read. And you want to read it in binary format because what you stored there is machine language, sorry. Then after that, you can pass your x and your y value, the independent and dependent variable, to fit your model. And after fitting the model, you can use it maybe to test the score. And after testing the score, now you can get your result accurately, just the same way you can do. So what we did, we loaded our model. We were able to dump it and to load it perfectly. So important learning materials that we have are two. This for Lambda I have shared, and this another one for pandas data frame method. I think I'm done. What I'll do now, I will push the code to GitHub. When you're looking at me, I won't create a branch. I'll just do it the basic way of doing it. So I'll push this code to GitHub. Maybe I can go to GitHub and create a new repository. Yeah, we are done. You can be typing your question or unmute yourself and ask any question that you have. Those who want to remain to get the link to the resources that I was using, you can still remain. I want to use, maybe let me use this. Should I? Let me create a new repository here so that I don't use any organization. But so this is deploying the mesh model using Flask. Public, then I create, then I'll come here. I remembered I'm not sharing my screen, so let me share the whole screen so that you can look at it. I'll stop sharing that and share the whole screen. Yeah, we'll share the... No, I've done the wrong thing. I've done the wrong thing. Tell me if you can see up to terminal everything that I have in my screen. Kindly unmute your mic and confirm you can view everything. I want to be creating a branch for progress. I'll just be using the main branch. Can you see my screen? Someone type this yes or no, if you can see my screen. And I want to, yeah, thank you. So what I will be doing, I will be pushing the code on GitHub and share the link. We'll do it together. So I'll start with Git in it, initialize it, then Git, and oh, this is a very dangerous. Okay, let me start from scratch. Then I clear. Then I move back twice. Then I move back again. Then I clear. Now I have to navigate to where my folder is. So I'll move to desktop. Then I'll move to the folder that contains our files. Then and I'll use tab to shortcut it. Then I'll list to see that everything is there that I want to push. I can clear my tab. I can write git in it. I think I ran it again. Yeah, initialization. Then I can git add. And when you're using git add, or make sure that whatever you want to add is whatever exactly you have in that folder. The next step after that, after git init and git add, is you commit message. There is a shortcut for this. You should look at it, where you use git commit or instead of where you want to add or add commit them. There is a shortcut for that, but I won't be doing it now. First commit. Okay, there is another thing I want to make clear here. When you're committing something, a lot of developers prefer to use the present tense. Don't use past tense. Like I added files, just add files. And first files. A lot of people naonanga they use present tense, or they use past tense. Then after that, I will write git. Let me copy this to speed up so that I can share the link very fast. These two, copy, and I'll paste. Then git push to origin, branch name, main. We just deploy automatically. Then thank you. I can refresh the page and share the link with you. Okay, another thing I want to make clear, on 20th this month, I think is on, just let me be sure, on Tuesday, you'll be having a session with the developer of this website, data.sh. It is very easy to deploy an application there. Flask apps. Yeah, it is very simple. Let me go back and start Open Docs directory instead. It is very simple. You don't need Git, you don't need anything to deploy anything on data. So we'll be having one of the core team from data. We will actually show us the process of deploying a Flask application on this cloud service. Okay, dark mode. Then now you'll be showing us all this process using Flask application, Fast API, sorry, or Flask. Talk with him on 20th, just exactly like now. So I'll share that documentation so that you can look at it. Okay, another thing I wanted to share is the Twitter handle for Data Science East Africa. Please be sure to follow us and share about us with your friends. Now, unless you have any question for me, I think I'm done. Any question that you have? Let me explain to you what I was talking about. Creating Python modules. Okay, and if you want to, if you have a question and you text me WhatsApp, currently I'm not very active on WhatsApp, but you can get me on Twitter. Let me share my profile link to my Twitter handle. You can just check me there anytime you have a question for me. Yeah, here we talk. I'll answer. Now, I wanted to explain to you the setup file in Python. for developing Python packages. Then I have to pick the best article, I think, from Medium or Free Code Camp. Yeah, this is very important. Exactly the one that I was looking at for. So you are there, you want to create your own pandas, you want to create your own NumPy. If you want to create your own pandas or your own NumPy, you have to create the file that will work. Then you have to add just one more thing. And that one more thing is the setup.py file. This is the file that helps you to build your own Python object. And now you'll be able to install it just using, you can see, very simple module. He built a module called very simple module. Yeah. Here is where he defined. It's just like any other JSON format. Then you use the setup file after building your own object, like he built his own module. Then after building his own module, he created a setup file, then stated everything very clear from version to description, everything that he wanted. Then after adding them to the PyPI, then he was able to install it. And you can check the version of your module that you created. So I think if you need a session on the same, we can have one. Just say when, if you're interested in this topic, we can discuss. Yeah, just type on the chat box. Just to be clear, the class is over. You're just hanging out after the class. If you have any question, you can leave for me. Anything that you want. Let's see about this. So you can go and read about the setup.py file. It will help you a lot when you want to create your own module, when you want to package, especially the guys who are in the crowd services or anyone who wants to major in machine learning operations.